Welcome to our presentation about the future of Postgres in a multi-cloud world. So that's going to be a presentation that Bruce and I are doing together. Just to introduce me briefly, I'm in charge of product development and support for Enterprise DB. And Bruce, you want to introduce yourself?
Yep, Bruce Momgen, Postgres core team member, worked for Enterprise DB for 14 years now, and I work for Mark.
All right, so let's get this going. So Bruce, I know we've put together a little story here. Do you want to introduce the story, and I'll play the developer role?
Sure, great. So there's been some major changes, obviously, in the industry. I've been in the database industry for, I guess, 30 years now. And obviously, things have changed quite a bit. And our goal of this presentation, from a database perspective at least, is to talk about how some of those changes impact you, how some of those changes look going forward, so you can be prepared for the type of work environment you're going to have going forward. The particular story we have here, Mark, is basically somebody being a DBA and somebody being a developer and somebody needing to figure out, gee, like, how do I create an application now?
Yeah, and we're doing this from an agile perspective, right? So we're not walking in with a phone book sized spec. We're just being told, hey, we need a new app to manage signups and badges for a trade show, right? So that's pretty much all we know when we start our process. So now there's a bunch of questions here, right?
Right.
So,
like, for example, yeah, like what are you going to be needing to store? Is there any persistent store needed for this application? Frankly, almost most applications need some kind of persistence, Mark, right?
Sure. And then, sometimes you know exactly what you're going to persist, right? Sometimes you don't, right? I mean, in this example here, we don't know how many phone numbers people will give, how many email addresses. Some give us none, some give us 3, right? So personalization is going to be, I think, of major importance.
So you're looking for flexibility, basically.
Flexibility and the ability to say, oh yeah, I want to store 2 more phone numbers. Oh yeah, my secondary phone number is called my mobile number. Somebody else will have an office number. Somebody else will have a number in their UK office, right? So we don't even know what the fields are called. So something like JSON-B probably going to play a major role here.
But then you need to choose like the software. You need to figure out where you're going to deploy it. You need DBA. Like, what type of durability do you need?
Yeah, and
a lot of questions here.
Right, and because we're in an agile process, we don't have that phone book sized requirement spec, right? So we can't all look it up. We'll find out as we go. So we need to have a lot of flexibility, a lot of capability, so that we don't lock ourselves in. We also don't know if we can, if we can or should run on the corporate Oracle contract, right? Should we commit to Amazon? Should we commit to Azure, right? What is this going to run on? We don't know, but we know that at the end of the first sprint during the review, we want to show a first amount of progress. So that's I think what characterizes a lot of the new development processes, and what we can see, because we may need a whole lot of features. We don't know all the features that we need on day one. So having independence and having flexibility is really, really important.
But Mark, isn't there sort of an inherent contradiction? You want persistence, meaning you want stability and the ability to keep data over a long time, but at the same time you want to be agile. How do you make those both work?
Well, I think, obviously we're both a little biased, right? That looking for a persistent system or a database system that gives us as much flexibility and as much capability as possible, that's an important thing. The second thing then is, because we don't know yet how much money we will be able to spend, find something where vendor lock-in doesn't play a role, because we don't know yet how many, where it's going to run. Making sure that we don't have a platform lock-in is really important. So that drives, in the old world, decisions towards a certain framework. In the new world, I think you and I were going to show that yeah, many of the ways of thinking about this can change now.
Yeah, that makes
So,
sense.
right, if I look at the old model, right, traditionally, when I was a developer and somebody asked me a question like this, well, I didn't know what database platform I could use. I didn't know where it was going to run. So my choice was have a high level of abstraction that actually, where I used the SQL standard. I would use an object relational broker to make sure that I'm not buying into any of the features of the database, because the moment I would buy into spatial, I was locked into Oracle, right? The moment I started using, let's say, TSQL or stored procedures on SQL Server, I was locked into SQL Server. My choices were limited. My cost was kind of built in, etc. So what I would do as an application developer is I would use as little as possible of the underlying infrastructure so that I would have as much flexibility as possible. The
Right. So
consequence.
you
Go ahead.
it was like you were given a hammer, and it better be a nail, right? Because all you had was a hammer, right? You only had
Correct.
one
Yeah.
way of going. Yeah.
Yeah, one way to go, and what happened is we started building a tremendous amount of business logic in the application layer, because we transactions, searches, comparisons, all that kind of stuff. We moved it into the application layer because we didn't want to commit to anything that was in the database, because we were afraid that that would, well, commit us to cost, commit us to an operating system, commit us to a certain cloud, commit us to a certain database vendor, right? So that's really what happened, right?
But
And,
you're
and
effectively implementing the database in your application there, right?
yeah, and we'll see what that really means, the impact of that, right? Because
Yeah.
let's imagine I have two parts of my data set. I have orders and order lines, and I want to join them together in a certain smart way. Well, if I move all my business logic into the application, I actually suck up the data from both sides, and then I do whatever merge in my application, because I don't want to build on any kind of database logic.
Yeah.
So that recreates a whole lot of code. Now, what made that worse is that in the traditional way, I was bound by a corporate software catalog, right? So, and that software catalog would tell me there's two databases you can use, right? Big things, use Oracle. Smaller things, use SQL Server. And if you got no money, use MySQL. Okay, that's the traditional way. And the result was, because I didn't know how many users we would have, the transaction volume, whatever, I would use no features at all. I would recreate everything to avoid vendor and platform lock-in, because in my agile process, I didn't know a whole lot of stuff yet.
Yep.
So, so this is really what happened, right? That we didn't use the database features. As I said, we wouldn't use spatial. We wouldn't use a lot of the capabilities. We would not use PostGIS. We wouldn't commit to any of those features because they would cause lock-in. And I mean, Bruce, you've also read Dimitri's book, I think, where he shows that what the consequences of that is, and maybe you can elaborate on that a little bit.
Yeah. So obviously, relational databases have been around since the 70s, right? So what are we, year 50, right? Almost, or 40, or year, 50 of the relational systems. And the reason they've been around so long is that they give such a rich tool set of capabilities, both in terms of the SQL language, in terms of concurrency handling, in terms of data warehouse analysis, joins, where clause, syntax, management, durability, all these things, right? But as you said, a lot of people have been so disappointed, even either because of the lock-in, because if they develop it for MySQL because they have no money, and then they go to SQL Server where they got money, or to Oracle, now they got to retool the whole application, right? I mean, that's typically that's the flow that you're kind of saying. So they would say, no, I'm not going to use a lot of those features that are in that relational database, even though they could make my job as a developer a lot easier, my application more performant, my application more reliable and smaller, and get to market faster. I'm not going to use those because I may need to move to a different platform, as I get popular, as my project gets money, right? I mean, it's kind of crazy, but that's the way it works.
Yeah.
But the problem, obviously, as you said, is it just makes your job much, much, much harder.
Yeah. And not just much harder, it also, and then for those of you that may not know that book, Dimitri Fontaine has written a really nice book about the art of PostgreSQL, where he's making that argument with a couple of really nice examples. There's two other things that are happening. When you move too much logic, business logic, and too much data to the application layer, you're actually walking away from Postgres's isolation levels. You're leaving behind a key element of the ACID principle, right? Atomic, consistent, isolated, and durable, right? So you're leaving the I behind, or you're having a high risk of leaving the I behind. The second, because you're creating two different snapshots of the data, or two or three or four, and then you move those to the application and you work there, and then you recommit the changes back into the database. So unless you locked up all the data in the database, you may very well have left behind any kind of isolation, instead of just telling the database, do that and do it within the same transactional snapshot and guarantee consistency, right? But there's another aspect. You've moved all this data to the application, and you had to write your own logic as to how to execute this query, right? You had to, within a week or however much you had for this task, you had to recreate all the smarts that a database design team put into a planner and into query execution in years, in decades of work. Hardly ever works, right? So really, there's a significant danger of writing a lot more code, having an inconsistent application, and having an application that performs a lot lower if you're staying with the SQL isolation level because you're afraid of committing to a platform that you're running on.
It's really the big difference between using a database as just a data store, right, and a database, right? I think that's the terms I've heard. A lot of application programmers, because of bad history, bad experiences, end up just thinking of a database as a data store, and they're leaving a huge amount of functionality behind.
Yeah, that's true. So what's the new model? We're encouraging people to leverage the database, including the transactional capabilities, the atomic behavior, durability, but also leverage the capabilities of JSON-B, GIS. Don't write it yourself. Use it, because you write a lot less code, you get there faster, and your code is going to perform much, much better. And what Bruce and I are going to show you is that Postgres has changed so much, has evolved so much, that today you're in a position where you can trust the Postgres API. And we have a number of customers who've done that as a strategic decision, where they tell their application development teams, build on the Postgres API because it's going to run everywhere. And we'll make the case, we'll show you that indeed is true. And not only does it run everywhere, it also gives you vendor independence, because you can self-support, you can ask somebody else to support, you can use a managed service, whatever, right? So you have complete flexibility, and now you're finally in a position to say, yeah, I'm going to leverage the capabilities of one of the most innovative platforms in the world and not suffer lock-in into a vendor or a platform. So, one of the elements that we often underestimate in this is that developers drive decisions. Now, that means something really interesting. It's a really interesting consequence there, because in the past, a corporate software catalog was compiled by the architects, and that's what you had to use. And your corporate catalog might have, 20, 30, 40 things in it. Well, now developers with open source, they have a global catalog of thousands of things that they can build on and leverage for their application. So things are going to become are really moving completely differently. So let's talk a little bit about this. I mean, really, open source today is everywhere, and we'll show some interesting stats about that. It's very clear that in the database world, the relational database world today, Postgres rules the roost. But also Agile is something that we can't underestimate. And we can't underestimate that open source is really an element that enables agility. If agility is limited by two choices that are in the corporate catalog, you're not agile. You may call yourself agile, but you're not. Okay. And then Bruce will talk a little bit about the Postgres innovation, which is really spectacular. And we'll show you that, Postgres is really everywhere, all over the place. Performance is great, and that you don't have to worry about anything like vendor lock-in. I'm not going to spend a lot of time on statistics about open source. You all know them. But it's really phenomenal how many companies today say it is important. It's like in this statistic from Red Hat, it's over 89% that say that, hey, it is important. And there's only 1% that say it's not at all important. I can't even imagine who they are. Okay. So, yeah, don't buy their stock. But then also Postgres is extremely popular, right? I mean, we still know MySQL still has a very large footprint, but a lot of that is for historical reasons. But after that, immediately Postgres comes and is growing like a weed. And I mean, Bruce has been with the Postgres movement now for how many years, Bruce? 20, 25 years?
24, yeah. 24 now. Kind of crazy. I mean, probably the biggest change I've seen is that when we started in 96, Postgres was the thing that you just used if you had no money, right? Like the MySQL we talked about earlier. So, the idea, it was coming as something that didn't have Oracle features or didn't have Oracle syntax or didn't have Microsoft syntax or didn't have a big company behind it and all these things we didn't have. Now, in 2000, you walk up and you're like, oh yeah, we love Postgres and we love the API and we love the API more than we love the API of the commercial databases. That's a huge shocker to me, having been through this for so long. And you alluded to it, Mark, that effectively Postgres is the favored SQL API, even beyond the traditional databases that have been around for decades. And that's a tremendous benefit.
Yeah. When I got involved in Postgres 7 years ago, we still were evangelizing for Postgres. Today, and this is not a joke, Bruce and I were at a customer earlier this year where they said the Postgres API is the API. Everybody develops to the Postgres API. And this was not a small company. This is one of the really large retailers in the US. And so when that happens, you can actually see that, Postgres has won. Now,
and even other relational databases are now programming to the Postgres API.
That's correct, right? Yeah.
I'm not going to go into specifics, but when we add a syntax, it shows up.
Yes. So and what's also important, I think, to emphasize here that even in completely new things, right, where we're really changing the way we work with data in containers, it is the number one. It's way ahead of MySQL, right? It's only Nginx as the web server is more popular in containers, according to this statistic from Datadog from last year. So it's not just in the stodgy, let's say we need great precision with our data, et cetera. It's also in the new stuff where Postgres is extremely popular. So talking a little bit about the new stuff here, Bruce, just talk a little bit about the innovation that we're seeing here and why Postgres is such a safe bet also. It's not just, it's been around for a long time, but it's more vibrant and faster moving, I think, than any other data management platform out there.
Yeah, that's really true. It's kind of a shocker going up against billion-dollar companies and producing database, software that's effectively very similar to them. You would think that the teams that we've had for the past 20 some years would never be able to produce software of the similar quality or capabilities of billion-dollar companies. But as you know, Linux, Engine, all these huge open source projects have attested, open source is such a superior development model in terms of harnessing the capabilities of people, around the world and their skills to produce, amazing software that effectively, we've been able to produce at least beyond parity, I would say, in terms of features at the database, at the developer level, in terms of what our database can do, whether it's so our extensions, object relational nature of the system, GIS, an amazingly popular GIS, geographic information standard, probably the most popular. JSON-B, certainly the most popular JavaScript relational embedded capability. Our extensible data types, the foreign data wrappers, the full text search we've had for over a decade. These are hugely complex things, but they enable that database to do so much unusual workloads that you never would be able to do on traditional relational databases. Company proprietary databases are trying to sort of keep up with Postgres and innovation, but it's really hard for them. Companies don't innovate very well. They kind of like say, oh, let's go in one direction, and then next year they go in a different direction. It just doesn't work very efficiently for these companies to innovate. And obviously, Postgres being around and having parity in terms of features is now sort of in this huge innovation phase where we're thousands of people are talking every day about, hey, let's add this feature. Let's do it this way. Let's make the syntax look like this. That variable name is wrong, right? From big to small, you see thousands of people just kind of working on this huge project. And the quality of the releases, the 170, 180 features we put out in every yearly major release is a testament to that, just continual innovation. You see it in other open source projects. Postgres, I think it's in the database realm, is sort of the biggest one where you can see that energy coming through, and the feature set that you see new every year being released at the same time in a very reliable way that gives people confidence to use the system.
Yeah. And I think you combine that when you think about our initial set of concerns when we build our new app, right? Do we need GIS? Do we need personalization? Well, even if we don't know, Postgres is a safe bet to start with, because if it turns out that it's not just badges for the conference, but it's also where's the nearest hotel or which bus stop do I take? Now we can just build on it. We have GIS capabilities all built in. So the other part that we were worried about is, well, where am I going to run it? I don't know yet. Well, the point here is that Postgres today runs everywhere. I mean, there's platforms on here. There's Arduinos. It runs on Arduino. I should probably add that to the list here, right? But you can run Postgres today everywhere. And there's probably, on Nutanix, on VMware, on any kind of Red Hat, on Kubernetes. It's on AWS. It's everywhere. So it's a pretty safe bet to build on. You're not going to lock yourself in. Now,
and Mark, going back to what we talked about earlier, if why people avoided closely aligning their applications to the database was that lock-in concern, right? And the lock-in concern was basically the very typical story. You start using a database, you start using its features. 5 years down the road, all of a sudden, prices go up, prices go up. And you're locked into that specific vendor, you're locked into that specific database, and unless you want to put a huge amount of money to port it to another database, you're stuck paying the check. And I think this slide really illustrates clearly the idea that if you don't like AWS, you go to Azure. You don't like Azure, you go to Google. You don't like Google, you go to Red Hat, or you go to Kubernetes or something, or Nutanix. So you have this incredible spectrum of options, which really prevents any one vendor from abusing their relationship with you. I think that's, I don't want to, make it sound too emotional, but there is a certain sense that once you were into the ecosystem of proprietary databases, there was the potential for that relationship to be abused by the vendor to increase their revenue. And although that's always going to be there for every company, there's a counterbalance here. because you have
Right.
the ability to easily move without having to modify your application, and also having so much feature set in Postgres itself. Odds are you're not going to need anything beyond what that feature set currently is.
That's
That you're probably not going to need to
that,
leave Postgres, and you're going to be able to move to pretty much wherever you think it's most efficient for you to deploy.
that's correct. And then you add in there that in all those platforms, you have a support choice, right? You can self-support. I mean, there's limits to what depending on your staff and how much time you want to spend with it, whether you should do that or not, but you can, right? You can run it as a managed service. I mean, there's managed services here that I'm forgetting. Alibaba, for example. KT also has a cloud.
Heroku is another one.
Roku, yeah,
Yeah.
absolutely. So the choice is really the choice is great, and again, as Bruce said before, it runs everywhere. But then even on all those platforms, you have multiple vendors to choose from. So if you don't like the relationship, change the relationship, right? We're trying to make the argument here that when you choose Postgres, you don't need to worry about platform lock-in or vendor lock-in, right? So Postgres really, helps you deal with that problem in a very, very efficient way. Now, you may say, I don't care. I'm just going to use whatever. I'm going to just want to dig in all the way. Well, what we see now, what we hear from our customers is that over 50% of our customers are using multiple clouds. I mean, for some, cloud can mean on-premise, right? VMware cloud,
Private cloud.
but public cloud, right? And most of our large customers today, they don't want to be tied to one cloud, because there's no reason why one cloud vendor shouldn't abuse the relationship in the same way certain database vendors are abusing that relationship today. So it's really important to stay in control. And again, Postgres gives you a great way of doing that. And that's why, cloud agnostic architectures is something that a couple of years ago was propagated by analysts, but we're now hearing it from customers who say, hey, also please make sure no cloud service provider lock-in, because I want to be able to deploy anywhere. I want to stay in control of my cost. And I need to be able to push my workload wherever I want to. Maybe I want to develop on AWS and deploy on Kubernetes, on OpenShift, on-prem. I want to be able to do that. Postgres gives you that. Okay. Now, one of the other factors around lock-in concern was, well, what performance requirements do I need, right? If I stay with SQL, then I can at some point in time also say, well, I'm going to go onto Oracle RAC or something really, really big, depending on how successful my app is. And I think one of the things here that you all need to be aware of is that Postgres has evolved tremendously. The blue line here, the print's kind of small. The blue line is Postgres 9.5. That's 4 years ago. In 4 years, Postgres TPS in this benchmark, and this is exactly the same machine, exactly the same configuration. In 4 years, Postgres has gained over 50% performance. Okay, and there's no reason to believe that that's going to slow down in any way. Okay?
Well, actually, Mark, we had a patch that almost made it into 13, which would have kicked this up for 13. So 14 is going to have another jump for sure.
Yeah, and again, so Postgres is again a safe bet here. You've seen the features. I think it's the fastest evolving feature landscape. You saw the vendor independence. You see the performance growth here. So from a lot of different perspectives, it's a safe bet, and it's especially, we had the zombie on the prior slide there. This is no zombie. This is really fast moving. So it's a safe. And for me as an application developer, I know that an app may start quickly, but if it's successful, it's going to have a 5, sometimes even 10-year lifespan. So betting on something that's going to carry you forward and not turn out to be, just a corpse, is really important, because we all know applications that have bet on platforms that did not evolve and couldn't keep up and needed to be migrated with lots of cost. So Last concern that we often hear is enterprise scale, right? I mean, can you manage it? Can you back it up? Can you manage it at scale? And we're there today. I mean, there's monitoring management tools, backup tools, all the things that are required to run Postgres with really high availability, really high service levels. There's hybrid data integration with SQL Server and Oracle. There are CDC tools. All those capabilities today are there. So um, again, that's an area where if you don't know how the technology requirements are going to evolve, you can bet on it. It's going to be a safe bet. Gartner Gartner's Magic Quadrant kind of confirms that um, Postgres today is the only open source based relational database management system in the Magic Quadrant. If you page back in the Magic Quadrant in prior years, there were other ones in there. They're all gone today. And that's a combination, I think, of all the things that we talked about, the features, the performance, the innovation, but also the tooling that makes it usable at the enterprise level.
And the other thing, Mark, is the challenge for development is always how do you get innovation quickly while maintaining reliability, right?
Yeah.
And that's really, I think, the area that open source really is stellar in, because of the way the development happens, because of the way there's so many people looking at the code, looking at the patches, analyzing what's going on, testing continuously. It really gives you the best of both worlds, huge amount of innovation, but then tremendous reliability at the same time. Almost impossible to do inside a company where the source code is not open to the world.
Mhm. Yeah, yeah, I think that's and the Postgres project I think has done a very nice job as focusing immediately on reliability, on controlled releases, high quality, etc. So that's really showing up in these results. So just in summary here, what's changed, right? Postgres is available everywhere and from lots of different vendors and no vendor. That's important. So there's no vendor lock-in, there's no platform lock-in. I think the capabilities when you compare Postgres to what you get from other vendors are just phenomenal. The flexibility, especially as a developer, and I would really encourage developers to dive in and look at things like operator classes, etc., that they don't exist in any other database management system. And initially, as a developer coming from Python or whatever, you may say, why do I need that? I can just write it in Python. Well, take a look. You can write much more efficient code, less code, faster code if you take advantage of these things. And that is safe to do now because the performance is there, the portability is there, the lack of vendor lock-in, all of that allows you to do that today. And then, the really vibrant Postgres community driving lots of innovation is I think is the biggest argument I think in favor of Postgres. Bruce
Yeah,
tells
or
me,
you could just use server side Python, and therefore you just write your Python in the server. You don't have to write it in the client
yeah.
anymore, right?
Bruce also always tells me if Postgres was just a cheaper Oracle, then people wouldn't be coming back in droves to the Postgres conferences. And we see that once people understand the power of Postgres, they don't walk away from it anymore. It's not just a cheaper Oracle. It's,
Yeah.
I think, actually a better database. So lessons from this, don't stay with the SQL abstraction layer. Take advantage of the capabilities that are there. It's safe. It's safe to do that today, right? I mean, when I was an application developer 20 years ago, well, as soon as you dove into Oracle, it was great. You could get a lot of stuff done really quickly, but you had committed, and you were committed for life, basically, or for the life of the application. And here, yes, you commit to Postgres, but that doesn't commit you to a vendor, that doesn't commit you to a cloud, doesn't commit you to an operating system. You can, pick any vendor you want or self-support, and I highly encourage you to enjoy the freedom and innovation of open source. So now we're going to open it up for questions.
Okay, thank you, Bruce and Mark. We're going to jump into the questions now, and the first one up comes from Mike Sanders. How do you feel about the proprietary forks such as Aurora Postgres and how they fit into the vision of Postgres overall? Bruce, what's your opinion first?
Okay. I think Aurora Postgres is just one aspect of a whole bunch of forks of Postgres, whether it's Green Plum or Astrodata or I think Alibaba has a version. There's just Postgres Professional has a version. Second Quadrant has a version. They all have. A lot of companies have proprietary versions of the server. And effectively, what they're trying to do is to meet a specific need for their customer, their market, or in the terms of Aurora, to tailor a database specifically to their infrastructure. And I think it's a very interesting approach because, of course, as big as Amazon is, they're really not a software company. And by taking the Postgres source code and sort of tweaking it to get the best performance out of their particular cloud hardware, they're able to, I think, do some unusual things with it that maybe you couldn't do with just a standard version of Postgres. So, we consider all the forks, whether it's Aurora or Alibaba or any of these other companies or Enterprise DB's advanced server, as really just taking the database in a direction closer to the needs of a specific market. If that market's big enough, over time, Postgres will evolve in that direction. If that market remains a niche, then that vendor will just stay with those customers. So we don't see that as a threat to us. We see it as just taking the software and bringing it to a new market with new capabilities, new features, new scaling opportunities. And we don't feel that they really diminish Postgres in a way they actually help to cement its popularity.
Great, thank you. Mark, do you have any thoughts there?
Well, I'm aligned there with Bruce. I mean, it's a fork of Postgres. Obviously, we would welcome if companies such as Amazon would contribute also into the community, not just take from the community. And many of them, like for example Azure, is actively doing that, and others that we mentioned on that list of clouds are also very actively contributing patches back to Postgres. It's less of a danger to Postgres than it is to other open source projects that are more funded by single companies, right? Because Postgres is a true open source movement, meaning there's a lot of people contributing, whereas other open source or so-called open source projects are really single company projects. So those single companies then have to defend their turf very actively with altered pseudo open source licenses, etc., when the cloud vendors come in. Whereas for Postgres, it's really about having them all participate. And past experience has shown that very few Postgres forks have lived in the long run if they did not stay closely aligned with the community, because you lose the open source advantage, the leverage, the cost from the cost perspective, as soon as you stray too far from the community. So contributing back to the community is actually a very good economic move, and so we're seeing less threat there than let's say single company open source movements like, let's say, Mongo or others may be concerned about.
Okay, great. And that actually leads pretty well into the second question. What influence does EDB or any other Postgres vendor or the Postgres community as a whole have on the major cloud providers, where they're looking at whether it be AWS or Alibaba was mentioned, Azure, GCP, to actually include additional extensions? As an example, where RDS has a specific list, I know GCP does, and so does Azure.
Yeah, some of the cloud providers have limited support for extensions because of the way they deploy Postgres. So, for example, if you're going to deploy Postgres, but you don't want to give the customer root access to the VM or the container, then effectively you have to disallow any super user commands that could interact with the operating system. So a lot of times it's security requirements in their particular setup that prevent them from supporting it. Um, uh, we really have no control over what things they support. Sometimes people collar me at a conference, hey, can you move something into core? And I'm like, well, why? And I'm like, well, Amazon doesn't support it. I'm like, well, that's not really a good reason for the community if we decide it's better in a contrib module or it's better as an external extension. Bring it in to force Amazon to bring it to ship it is certainly not something we're going to consider as a community. That's really not part of our calculus.
Right. That kind of steers away from the freedom of the overall community intent as well, right? And alongside that, there was a question posed regarding licensing. Could either of you elaborate on whether something is specific within the Postgres licensing that legally protects an individual from getting a vendor lock-in? There's a lot of PostgreSQL solves, all of these things, but the question specifically is how. What is unique about the Postgres license that you don't see in, let's say, GPL licensing or elsewhere?
I think and Bruce, you should chime in because you've been with the movement much longer and have been, at the root of some of those decisions. But the fact that Postgres the Postgres license uses slightly modified BSD 3-clause license, makes sure that Postgres is completely open. There's no dual licensing scheme. There's no the mechanism that is implemented in so many of the so-called GPL licenses or others, where you, as a contributor, actually sign off that you've given the copyright to a potentially private company, right, that can then do with the copyright whatever they want to do, right? Those things don't exist. And at the same time, I think Postgres also, through its organizational structure and the way it handles the core team, makes sure that single vendor influences just they don't work. I mean, it's organized. I don't know if I've asked Bruce often whether that was intentional. I think to some extent it was when they put the whole process together many years ago. But it really assures, from a licensing perspective and from a process perspective, that nobody can buy Postgres. You can't take it and make it proprietary. And Bruce, you should weigh in, sir.
Yeah, it's a great question, and it really comes down to, I think, the confusion between proprietary and open source. And everyone understands what proprietary is. It's been around forever. It's closed source. Only the companies can see the code. That's pretty clear. With open source, because it's relatively new in the industry, a couple decades, people have distorted open source in different ways. And I would argue there's two types of open source. There's the open source that Postgres is, which is effectively a BSD license. No single company controls it. Any company can produce any version of the software, proprietary or not, ship it if they want, put it in the cloud. There's no requirements. That certainly reduces lock-in. And there's the second type of open source, which I almost think of as open source distribution or open source marketing, where the company controls the license, they control the GPL requirements, they control whether it can be run in a cloud environment, right? You've seen some changes from vendors in terms of their relicensing sometimes of open source to prohibit, for example, running in the cloud. And that sort of middle ground, where you've got this sort of company controlled but open source distributed software, MySQL being the biggest one, Mongo probably being the most current one. Those can also produce lock-in. And we've seen it with Mongo, we've seen it with MySQL, where it's kind of like, don't do anything that kind of harms the company too much, or they're going to find a way to come at you. The open source nature of Postgres, both in terms of the source code and the distribution of the software, I think, means that you can get it anywhere. It will be deployed everywhere. It will be on all the clouds. It is supported by companies in Chile and Russia and China and Japan and Korea and so forth, where you've got this just smorgasbord of options. And I think that openness of no control of the software is what really reduces the lock-in, because again, as Mark said earlier, if you don't like your vendor, it's time for a new relationship, find another one.
Right.
And I think the fact that there is no single entity that you assign your copyright to, so that means there's no single entity that can say, oh yeah, tomorrow it's all going to be under BSL license or something else, is not possible. It just cannot be done. So the protection that was built into the mechanisms of how the core works, how the community works, really assure that.
Great. Thank you both. One last question, as we're running a little bit short on time. A question posed by Chris. Are the later releases, such as 11 or 12, or the upcoming version for any plans ahead of Postgres STIG'd? Or sorry, are they STIG compliant? Are they available in secure environments? And Mark, I think we've had some fairly recent news on the STIG side of things.
Yeah, absolutely. I mean, EDB just published a STIG, or just got approved a STIG by DISA for EDB Postgres Advanced Server on Windows. We also have a STIG, or has an approved STIG for EDB Postgres Advanced Server on Linux. So, definitely we are planning to maintain STIG compliance. And for those that are not aware of STIG, it means a secure technology implementation guide. It is issued for the purposes of the DoD, but the guide itself and the questions and how to answer the questions are public and very, very useful. So that's a little over 200 questions that describe in detail how to secure your Postgres implementation to meet DoD requirements. But obviously, these same questions and answers can be used to verify any implementation. So yes, we are committed to maintaining STIG compliance, and for anybody who wants to run a secure Postgres setup, they should check out the STIG questions and answers.
Great. Well, thank you both. I want to thank everyone for your time here and the overall attendance. We've had some pretty good questions, and we've got a number of additional questions that have been posed along the way. We'll try and do what we can to do so outside of the forum as well. Certainly feel free to continue the conversation outside of here. We've got a number of talks ahead for the rest of today, and I want to thank both Bruce and Mark for the tremendous presentation here. Thanks, everyone.